So today we'll be talking about the second part of the lecture, that is rate law. Rate of a reaction is a function of, we know that temperature, pressure, concentration of various species and presence of catalyst or inhibitors. We have discussed this in the first lecture. So the rate of a reaction is a function of the temperature of the reaction, the pressure, the concentration of various species in the reaction, and the presence of catalysts or inhibitors in the reaction. Now, for homogeneous reaction, the rate of reaction has been found to be directly proportional to the volume of the phase, because the reactants will be completely soluble within the phase and not be heterogeneous. So it has been found that the rate of the reaction is directly proportional to the volume of the phase. For heterogeneous reactions, it has been found that the rate of the reaction is directly proportional to the active surface, because the reactants come and get attached to the reactant surface when they get enough activated energy, they react between themselves and then they get out of the active phase. So here we can see that the active phase plays a crucial role in the reaction. So it has been found that the rate of the reaction is directly proportional to the active surface in the case of heterogeneous reaction. So we can write for homogeneous or a heterogeneous reaction that the rate of the reaction is equal to volume multiplied by the function of temperature, pressure, reactant concentration, and the concentration of the inhibitor or catalyst, whichever has been used in the reaction, plus the area multiplied by the function of, similarly, the temperature, pressure, concentration of the reactants, and the concentration of inhibitor and catalyst. Now this is known as the rate law of a reaction. This is a general form of the rate law of a reaction. The rate law of a reaction is determined experimentally. This is very important because no rate law can be found out by just doing theoretical work. We need to do experimental work, get the parameters on which the reaction depends, and then we get the rate law. For homogeneous reactions, this is the formula: d(epsilon dt) is equal to volume multiplied by the function of temperature, pressure, concentration of the reactants, and the concentration of the inhibitor or catalyst. So we know that the rate of the reaction d(epsilon dt) divided by V can be written as this way: d(epsilon dt), this way, and that is the function of temperature, pressure, concentration of the reactants, and the concentration of inhibitor. So in the next step, what we do is we know that d(epsilon dt) is equal to 1 by mu I dni dt from the first lecture, and 1 by V d(epsilon dt) is equal to 1 by mu I by V. We have divided both sides with V and we get this expression. Now we know that d(epsilon by V dt is equal to 1 by mu I dCi dt, where Ci is the concentration of the reactant. So the rate law comes down as d(epsilon by V dt is equal to k C a to the power alpha, C b to the power beta, and C c to the power gamma. This is known as another general form of rate law, where Ca, Cb, Cc is the concentration of the respective species, K is the rate constant, and alpha, beta, gamma are reaction orders with respect to reactant A, reactant B, and reactant C respectively. So the overall reaction order is the sum of all the orders of the reactants. The order of the reaction with respect to various species must be discovered experimentally. Again, the same thing. This must be determined experimentally and not by theoretical calculations. The order of a reaction with respect to a given substance has no relation whatsoever to the stoichiometric coefficient. This is always a piece of confusion for new students, that the order of a reaction is dependent on the stoichiometric coefficient of the substance as defined in a balanced chemical reaction. Suppose the chemical reaction is written as this way: A plus B plus gives D plus E, where E is the stoichiometric coefficient of E, but that doesn't mean that it will be included in the rate law as the power of this reactant species, or B will be included as the power of this reactant B in the rate law. It has to be found out experimentally, and it does not depend on the balanced chemical equation.